We'll talk about this more later, but is this relationship linear? No, the model that Toby articulated well was that actually maybe
the name of it was
curvilinear or parabolic or whatever, but it's definitely not linear. So here you could say the model that Toby articulated well is like, oh, you make some friends, you get happy, and then you have too many friends and it stresses you out or something, I guess.
This was the first graph,
but it wouldn't make sense to model this with a linear trend line. Like, what would a best fit line look like here?
It would cut like straight through.
Yeah, it kind of, maybe you can go like this, but clearly that black line doesn't really represent the relationship. Christine, do you have a question?
Yeah, the first graph, is that just like ideal, like what you expect, and this is like actual?
They're just
They
two
both have
sides.
no friends.
They're two different.
I just think,
The positivity and one shows the negativity.
I'm pretty sure that this is made up data. Why am I sure it's made up data? Because it's pretty hard to quantify happiness. I would say it's even harder to quantify friends, and hopefully if you're quantifying friends, you're doing, hopefully you have more than 4 friends, right?
Yeah, like what are you counting a friend?
Why does
That's
it go
all my
to
friends.
negative 2?
I already have
Why does it
like
start
11
with
friends
negative
right
2?
here.
Can you really have like enemies?
Alright, Toby, thank you. Alright, Tanner, you go and then...
Okay. Can you open up the? I just sent you another one with the PowerPoint link because I made a correction to it.
Alright, come join us.
Okay, mine. Bivariate data. It's kind of an obvious one that you could all probably guess the correlation between height versus shoe size. So it's not too much of a shocker that there's a pretty heavy positive correlation. The taller people get, the bigger the foot generally is, the bigger shoe they wear. The trend line had an equation of like 0.23x minus 5.66. So it's a slightly positive slope and a correlation coefficient of 0.62, so a little more close to 1. So as x increases, y increases. And I extrapolated saying someone who's 83 inches tall probably has a shoe size of 14. So it goes a little bit off the chart here, but then I kind of just like guessed that would meet it up there. Let's say 14. And my source was StatCrunch.com.
Okay, good. So where did StatCrunch get this data, do you think? Do you know?
They found
We
people.
can click on it.
I used it before too. I think like users put their own.
Yeah, I think StatCrunch, I've been to this website before, and I think you're right.
Yeah, I think people plug it in.
Cool. Good. Any thoughts, questions, comments, concerns on this? Okay. Thank you. You're fine. Leave it like that. Okay. Alright, so let's move on to talk a little bit about this idea of correlation versus causation. So we kind of looked at some weird examples thus far today because I think some of the data was kind of made up and some of the data, namely the movie data, did not really show much of a correlation. Tanner's data did show a correlation. And this is where stats sometimes gets into like philosophy. But what does, was Tanner's correlation between his two variables, was that also causal? So what did you have on the horizontal axis, Tanner? Remind us.
The horizontal axis was height.
Height. this causal?
What is that called though?
So what does causal mean?
There's not really a correlation. Like, there's a correlation, but like, this height, the shoe size depend on height.
Those shoe size depend on height.
I mean, somewhat, but not entirely.
Okay, so this is something that I don't have any very good answers to, because when you sit down and think about it, much of statistics is centered around this question of, like, what does one thing cause another? And we'll look at a bunch of examples in 1 second where researchers are interested in asking and investigating that question. And so here, I don't know that we're so interested in this, but it's still fun to talk about. Like, does a bigger height cause an increased shoe size? Megan says yes, and I kind of maybe agree with her, but I also agree with Elspeth. Like, lots of things cause your shoe size, but what causes you to have a big shoe size? Like big feet, and what causes you to have big feet?
Your genetics.
Genes, and what those genes also cause?
Your height.
Like your height. So I guess you could say what causes a big shoe size? Like it's your genes, but
So the same thing.
it's kind of the same thing. Like your genes cause your height, your genes cause your shoe size. So because you have genes that make you tall, those same genes make you have a big shoe size. So I guess maybe genes are what lead to a big shoe size, but still it seems like height is kind of somehow leading to the bigger shoe size. A bigger person wears bigger shoes. And I guess, yeah, you could kind of argue it that way too.
But I mean, the data, it did have a lot of like points at the same height all the way up and down.
Yeah, why was that? Why did it have a lot of points at the same height? Or the same, you mean the same,
So
not
like
vertical,
someone
like
at like
one.
64 inches tall, there was someone with a shoe size of 6, all the way up to someone with a shoe size of 13.
And so I think this goes to Elspeth's point that though height impacts shoe size, other things do as well.
Yeah, wait.
Wait, I'm 5'4", that's 5'4", right? 6'4"? Size 13 shoe, what?
Right, 5'4" or 6.
64 inches.
I don't know.
It's a big plus.
All right.
Pretty clear.
Can anyone think of two variables that would be correlated and also really causally linked? Okay, give me two quantitative variables then we can scatter.
Quantitative?
Yeah.
What
What does causal mean? I don't know. I mean, one thing. Okay, yeah, one thing causes another. So causal spelled C-A, causal, kind of like cause.
Maybe.
So a causal relationship is a relationship wherein one thing causes another.
Hours spent reading and number of words in your vocabulary.
Yeah. Or even
Hours spent studying.
more broadly, we would really hope, you guys would all hope as students, that if you study more, what's that going to do?
GPA.
Better GPA. And so, surely, what impacts your GPA? How much you study? Is that it?
What courses
So, okay, yeah, well that's
How many
I don't know,
hours?
you know what I mean. What impacts your GPA? How hard your classes are, how smart you are, like whatever your innate intelligence is, how much you sleep, how well hydrated you are. How well. So, in short, there are a lot of factors, yeah? But this is where, like I said, stats become somewhat philosophical. There are many factors, maybe an infinite number of factors that lead to better GPA. But like, if studying were not one of them, why do people study so much? The fact that people study so much, we're pretty sure, I think you guys are all pretty sure, I'm pretty sure, that practicing statistics to some extent is going to make you better at statistics. Like, we're pretty sure that practice is not only correlated with perfect, we're pretty sure that practice causes perfect, right?
Perfect practice.
Perfect practice makes perfect. Okay, but this idea, like, we don't know for certain, but we're pretty sure. What's another thing that we're pretty sure has a positive or negative correlation, but also a positive or negative causal relationship?
Max squat versus vertical jump.
Max squat versus.
Okay.
Or thigh radius.
Okay, good. So good. Max squat versus vertical jump. So here, I'm assuming max squat essentially is like a proxy or a measurement for basically what?
How much
Leg
weight?
strength. And so the longer, the stronger your legs are, the higher you can jump, because jumping, though, requires lots of things like coordination. I could have really strong legs, but if I went like I wouldn't really jump high, right? But one of the big important aspects of jumping high is having strong legs. And so I think we all agree that yes, strong legs causes a high jump. So now let's watch a video where the speaker kind of addresses this, but puts a different spin on it.
We were wondering what that was, right?
Well, max squat is like how,
The maximum amount of
you
weight
do
you can
have a max squat, you just don't know what it is.
There is a maximum amount of weight you can squat.
Alright, so listen up.
I came here today to warn you about the dangers of ice cream. You may not be aware of this, but these innocent-looking cones full of sweetness are one of the major causes of drownings. And I've got the numbers to prove it. So if you plot a graph of the number of ice creams that are sold, and you compare it with the number of drownings, you can see there is clearly an upwards trend. And I think it's very safe to conclude from this that we should ban ice cream.
So that's
Yeah.
weird. And then why are those people clapping? I don't know. They're sick.
Because they know, they get that she's trying to like prove a point.
What up?
You lower it just a little.
Oh yeah, sorry.
It like sounds like it's projecting.
Yeah, I had this experience in my class before, or a different class. Yeah, it's kind of eerie, isn't it?
It is weird.
Yeah.
How's everybody doing? Ice cream.
Ice cream.
Ice cream and drownings.
Ice cream and murder in New York City.
Yeah, that's right.
Well, no, I think the crowd knows that she's trying to prove a point.
The crowd knows she's trying to prove a point. Raise your hand. What's the point she's trying to prove?
That like
Not all.
Megan?
They're not related. Cause like,
Well, they definitely are
Well,
related.
so it's not causal. Like, cause you probably get more ice cream when it's hotter, and when it's hotter, you probably swim more, and when more people are swimming, more people drown.
Okay,
They're
good.
correlated, but
So
they're
snaps, they're correlated, but they're not causally linked. And so this is one thing. We'll watch the rest of the video. She goes through. She makes some good points. She gives some interesting examples. But when you're watching this, it's really easy to be like, oh wow, I'd never be so stupid. Like obviously, ice cream doesn't cause drownings, but you will find there are lots of sophisticated social scientists and natural scientists who see some correlation and they say, that's it. This X causes that Y. But then if you dig deeper, you can find oftentimes like there's a lurking variable, like temperature in this case. There's something else that's impacting. But comments before we keep watching? You have something to say?
And like I know, like with autism and stuff, I think, cause isn't it like that the age where like autism like symptoms occur is also like right after the age when you get vaccinated. So a lot of people think that it's getting vaccinated that causes kids to become autistic, and that's why there's like, or that's part of at least why there's like a big war on like
Yeah, I think I've heard that.
vaccines.
Compared with the number of drownings, you can see there is clearly an upwards trend. And I think it's very safe to conclude from this that we should ban ice cream because it's very dangerous. Since you are all smart people, you've probably figured out there's something wrong with my example. What's really happening here is, of course, that there is an underlying factor, which is nice weather, you might have guessed it. And if the weather is nice, more people will go out swimming and unfortunately drown. And at the same time, more people will buy ice cream. And it's not the ice cream that's causing the drownings. And here it's really easy to see that there is something wrong. But jumping to an incorrect conclusion about causality when you see a correlation is the most often made logical mistake. And today my goal is to make sure that in the future you can recognize this mistake, and I really hope you can avoid making it in the future for yourselves. And I'll do this by just giving some famous examples. And the first one is really rather innocent. The fact is that married men live longer than single men. If you look at the statistics, you see that this is really happening. And women's magazines, they like to conclude from this that marriage is very healthy for men because it makes them live longer. Well, a friend of mine, he likes to joke that marriage mainly makes life seem longer, but that's because his wife is